Now that you know what polar form is and how to convert a number in complex form into polar form, let's go a little bit deeper and see some sets of points using the polar form. For that, let's imagine again two general complex numbers, w and z, given here in the normal way, all right? So we already know that z minus w equals basically c minus a plus d minus b I. We also know that the distance between these 2 points is given by the square root of this square plus that square. We also know that the angle theta, the argument, may be calculated as the tangent of d minus b, the tangent minus 1 of d minus b over c minus a. Right? You already know that this must be between minus pi and pi, but let's go beyond that. But we can also think of z minus w as a new point P with modulus now square root of c minus a squared plus d minus b squared, an argument tangent minus 1 of this divided by that, right? What does this mean? This means that for any 2 points, w and z, the argument of the difference between them gives us the angle between the line joining the points and a line parallel to the real axis, the same way as here. This angle is the same as that. I'll say this again. This means that for any 2 points, w and z, the argument of the difference between them gives us the angle between the line joining the 2 points and a line parallel to the real axis. That's what we have over here. Everything in this chapter is not new, it's just conceptual. You just need to understand mentally and figuratively what you are actually looking at when you look at the paper and you see the numbers. All right? So this is what it means. So let's look at some examples. If we say that the argument of z is pi over 4, what does this mean? Okay, apparently you may think that this doesn't have anything to do with that. Well, but it does. You can just think of this as the argument of z minus 0. If this is pi over 4, let's look at this question again. At this sentence again. This means that the line joining the origin to the point z has direction pi over 4. This means what? This means that the argument of this point z, again the argument is an angle, is in a line that makes an angle of pi over 4 with, in this case, the real part of the Argand diagram. All right, it starts at 0. What if this is not 0? What if this is I, for example? So argument of z minus I equals pi over 4 again. What does this mean? This means now that the line joining points point I to point z has direction pi over 4, has argument pi over 4. So here is point I. So where is point z? Well, there's no way for you to know just with this where point z is. You just know its direction is on a line that makes an angle of pi over 4 with a line that is parallel to the real axis, and that passes through point I. What it means also if we have something like this. The argument of z minus I is comprehended between 0 and pi over 4. Now you don't know a specific argument, you just know that the argument may be something in between 0 and pi over 4. So instead of being represented by a line, it's a region that is comprehended between 0 and pi over 4.